Let's talk about the difference quotient. The difference quotient of a function f of x is f of x plus h minus f of x divided by h. This is actually derived from the slope formula where the 2 points you're finding the slope between are x and f of x, and then x plus h, and then f of x plus h. Notice if we do x plus h minus x, if we had x plus h minus x, this just gives us h because our x's would cancel out, and that's why our denominator there is h. And then we have the f of x plus h minus f of x. So usually I'll do a double underline for the y values and then a single underline for the x values. So again, f of x plus h minus f of x, and then x plus h minus x is just h. So this is our difference quotient, and the idea behind h is that we want it to be a small number. We want to make this as small as possible. So if x is 1, h might be 0.1. It could be smaller, it could be 0.05, and x doesn't have to be 1. If x could be 19 and you still have h be 0.1, okay? But here, if we had some arbitrary function f, then this would be f of 1.1 minus f of 1, probably numbers close to each other, divided by 0.1, and we'll get a number there. Our goal isn't to plug in a number for h. We want to keep everything in terms of x and h, and this is the biggest thing here. Everything we're doing with the difference quotient is setting us up for our second major topic in calculus. Okay, so I have the graph here because I just wanted to show you an example of kind of what we're looking at. So let's give some type of curve here. It doesn't really matter what it looks like, but maybe have some nice points here. So here, when x is 3, y is -1, let's assume I hit that point, and then this is going to be your x and then f of x. So I know we know the point is 3, -1, but let's just bear with me here. And then now we're going to pick some h and say, oh, here's a good h, and say this is x plus h, f of x plus h. We're just finding the slope between these 2 points. So here, we're just finding the slope between these 2 points, and there we go. As this value of h gets closer, this slope between these 2 points gets steeper. And you have to bear with my table here. It's not the best to write on, but as h gets closer to our value, our slope actually gets a little bit, actually doesn't get steeper in this case, it gets a little bit more shallow, but we're kind of trying to get to this point. Okay? So here in our next piece, we'll dive into this example.